I've got this ramp set up. I have a solid disc and a hoop. I'm going to release them both from rest. Let's see what happens as I roll down the incline plane. Okay, let's do it again. Watch carefully. Okay, I'll do it one more time. In fact, I'll even switch the positions just in case you think something's funny about it. Okay, so what did you notice? Every single time, which one of them beat the other down the incline? Let's figure out what's going on here. If the objects were sliding down the incline, they would be hitting the end of the incline at the same speed, but of course that's not what's happening. So let's use these cups here to figure it out. So the lemon line power ray is going to represent either work or energy. I have to do work to start off the system. Of course, I'm neither gravity nor spring, so I'm doing non-conservative work on the system. And I'm storing the energy as gravitational potential energy by lifting them up to the top of the incline. So they both have the same mass, and they're starting from the same height. They both start with the same gravitational potential energy. As they roll down the incline, of course, they're picking up speed, so the gravitational potential energy is transforming into translational kinetic energy, but remember, they're not just sliding down the incline, they're rolling down the incline. So now we also have to worry about rotational kinetic energy. Some of the available energy in the system has to go into the rotational kinetic energy cup. They're not just moving down the incline, but they're also rolling as they go. And so, of course, less energy in the translational kinetic energy cup means they're going slower than they would if they were sliding down the incline. Now, why does the disc always beat the hoop? Well, it's about moment of inertia. They have the same mass, right? And so for the disc, the mass is distributed all throughout, some near the edge, some in between, some in the middle, whereas for the hoop, all of the mass is on the outside. This makes it a larger moment of inertia. More moment of inertia means it resists accelerating in a rotational sense more, and so when we pour the energy into the cups, proportionally more of the energy has to go into the rotational kinetic energy cup to get it going, leaving less energy in the translational energy cup, and so translational kinetic energy cup, and that's why every single time this will be going slower and this will be going faster.